Hey folks, welcome to Screencast number 6. This one is all about intercepts. Yes, intercepts. So let's get to this. I don't know if you knew this or not. I certainly didn't until I read this. But before 1979, there was no three-point shot in professional basketball. Interesting. So pre-1979, no three-pointers. Players could only score 2-point field goals and 1-point free throws, similar to what we still have now. In a game before 1979, a team scored a total of 128 points. This situation is given by the equation 2x plus y is equal to 128. That, of course, is going to be a very, very important equation to use for this problem, where x is the possible number of field goals and y is the possible number of free throws. That is also crucial information. There's going to be multiple parts to this question, and the first part is to find the intercepts of the graph of the equation. No problem, we can do that. So if we look here on the right, here is a 1979 until now side of a basketball court, and then beforehand, the three-point line you can see is gone, which to me just looks really weird without the three-point line. I am so used to seeing it as well. But I wonder what changed it. I wonder why they implemented or why they put that in there. Something to research. Any one of you are free to do that. But before we start this problem, let's first establish what x and y are trying to say, because this is a real-world problem. And yes, we can put in all sorts of variables, but if they don't have any real-world meaning along with the context of the problem, it really is just nothing but numbers that don't have true, deeper meaning. We know every single ordered pair is x, comma, y. All right, well, that's going to help us a lot. But we also read that x is the possible number of field goals. So therefore, x is going to represent the field goals. And as we know from basketball, and as we know from just reading right here, field goals are 2 points. So let's just label that just in case. 2-point field goals right there. And then what about y? What does y represent? Well, it says right here, y is the possible number of free throws. So y are the free throws. Those are the number of free throws. And of course, a free throw, according to basketball, and according to right here, is worth only 1 point, just like it is today. All right, so that's good. We know that anything we insert for x is going to represent the number of field goals, and anything we insert to y is going to represent the number of free throws. So a quick example of this would be, let's say a team made, 8 field goals. So x would be 8. Well, keep in mind that would represent 16 points because every field goal is worth 2 points. So 8 field goals times 2 points each would be 16 points in total. And let's say a team scored 5 free throws. Okay, well, each free throw is worth only 1 point, so that's pretty easy math. That's 5 times 1, so they only have 5 points. So x represents field goals, y represents free throws, 2 points, 1 point, respectively. Let's move on. Now let's start actually answering this question. Find the intercepts of the graph of the equation. All right, no problem. We're going to do that very, very similarly to how we did it in class. Let's start with the x-intercept. Again, it doesn't matter which one you start with, x or y-intercept. However, for our purposes, let's start with the x-intercept because x comes before y in the alphabet. All right, well, we know the equation is 2x plus y is equal to 128, which is why x is multiplied by 2. From before, we said that every field goal is worth 2 points, so 2 times x would represent the total points from the number of field goals. So here we have the equation here and here. Now, to calculate the x-intercept, as we saw in class multiple times, to fall along the x-axis, the x-intercept, which is a point, must have one of its coordinates, x or y, to be 0. And as we analyzed and discussed and saw in class, in order for it to be the x-intercept, y has to be 0. And again, as we analyzed and saw in class, in order for the y-intercept to be the y-intercept, in other words, for the point to fall right on the y-axis, x has to be 0. So there are our zeros already put in. Because remember, every ordered pair is x comma y. X comma y. All right, so let's start doing solving for one of these x-intercepts. Well, we know that x is, I don't know, question mark. We're trying to figure that out. But we also know that y is 0, which means we can remove the y and replace it with 0. And upon doing that, let's start solving. It's almost like we're back in 7th grade, because 2x plus 0 is equal to 28 beautifully simplifies to 2x, which is equal to 128. And I'll bet at this point you can already see what x is equal to. Of course, it is going to be 64. Which means that we now know x is 64, and of course y still remains at 0. Alright, good. So we have our x-intercept now. It's 64 comma 0. Well, now let's calculate the y-intercept using extremely similar techniques. However, different things will be substituted. Now again, like we said, in order for the y-intercept to be the y-intercept, the point that lies on the y-axis, x has to be 0. So now we know x is 0, but what we don't know is this y. We have to solve for y. Alright, so knowing that x is 0, we can take away the x and replace it, of course, with 0. Now, remember, it's not 20 we're dealing with here. It was 2x, which means 2 times x, which means we have to take the 2 and multiply it by the 0. So make sure you're putting in some sort of indication of multiplication, whether it be parentheses, the little dot, the little tiny x, what have you. It's 2 times 0. But nevertheless, no matter how you look at it, 2 times 0 is nice and easy. That means it's 0. So all we're left with is y is equal to 128, and really we have our answer. Y is 128 and x is 0. So now we have our y-intercept. Our y-intercept, of course, being 0, comma 128, and again our x-intercept being 64, comma 0. So we're done with the first part. We have found the intercepts of the graph of the equation. On to the next. Alright, so you might be saying to yourself, okay, that's great. We have our x and y intercepts, but in the context of this problem, what does that really indicate to us? And that's what the next question is. It says, what do the intercepts mean in this situation? In other words, in the context of this basketball problem, those x and y intercepts, the 64, comma 0 and the 0, comma 128, what does that mean? How does that relate back to this real-world problem? Well, let's talk about that. That's a very good question. Let's answer that. It's actually not that bad to figure out. Again, we saw from before that x comma y, x was the number of field goals for 2 points, and y was the number of free throws for 1 point. So if we look at our x and y intercepts, here they are again. Let's start again with the x-intercept, which is 64, comma 0. Well, we know every ordered pair is x, comma y. So therefore, x is 64 and y is 0. So an x-intercept of 64, comma 0 means the team happened to have made 64 field goals. And how many free throws? Well, if y is 0, that means they didn't make any free throws, which makes sense too, because remember, this team scored 128 points in one game, which means if they scored 64 field goals, each of those field goals being 2 points each, 64 times 2 is 128. And no free throws means there were no 1 points added to each of those 128 total. So that makes sense. So in the context of this problem, 64, comma 0 means 64 field goals and 0 free throws. Now, the y-intercept, let's interpret that. Well, 0, comma 128 means x is 0 and y is 128. And going back to the context of this problem, in order for a 128-point scoring game to occur, another possibility, albeit an extremely far-fetched one, if you know basketball, and many of you do, would be that the team scored absolutely 0 field goals and they scored 128 free throws. Is it possible? Technically, it would be possible. Is it probable? Well, I've never seen it, and has it ever happened? You know what? It may have, but I can't really see that happening really that often. 128 free throws and absolutely 0 field goals? I don't know what type of dirty basketball this team's playing. But what have you, it technically is a possibility, and it represents the y-intercept. Now, which is more probable? 64 field goals and 0 free throws, or 0 field goals and 128 free throws, I'd have to say that the x-intercept is probably a more likely situation. But I digress. No worries, we have interpreted what these x and y-intercepts mean. On to the last part. Our final part of this basketball problem. If the team made 24 free throws, how many field goals were made? All right, well, we can do some basic mathematics to find that out. In fact, this is kind of a review problem from our previous unit when we were solving linear equations. Again, the question is if the team made 24 free throws, how many field goals were made? We have to remind ourselves, X were the field goals and Y were the free throws. What we do know based on this question is that the team made 24 free throws, which represent the Y value. So we know Y is 24, and it's asking how many field goals were made, which would represent X. So therefore, we need to figure out, question mark, what is X. All right, well, we can do that fairly simply. All we need to do is, well, in this case, which one do we know? We just determined we know Y is 24. So let's get rid of this Y, and let's replace it with, that's right, 24. And now solve for X, because once we have our X solved, we know the number of field goals were made. And all we have to do is use the basic arithmetic that we've been using for oh so long. Subtract 24 from both sides. This you already know to do. So we get 2x, of course, is equal to 104. And if 2x is equal to 104, we divide 104 by 2, and we get x is 52, which means this team scored 52 field goals. Of course, it's always good to check our work, so let's go ahead and do just that. All right, we know that, and get out of there, Y. Okay, so what was the equation again? Well, remember the equation was 2x plus y is equal to 128. And we just calculated the fact that if you have 24 as your y, your x is going to be 52. So let's plug and chug. Wherever we see an x, that becomes 52, and wherever we see a y, that becomes 24. Let's do this real quick. 52 plus 24 is equal to 128. And yeah, you can probably already see it at this point. 2 times 52 is 104, plus 24 is equal to 128. And yes, 104 plus 24 does equal 128. So 128 does equal to 128. You've checked your work. Congratulations. You know you've got it correct. 52, 24. So 52 field goals. 52 field goals. If the team scored 24 free throws, then they must have had 52 field goals if they scored 128 points in the entire game. Nice work. We are done with all three parts. Which leads us to your problem. This one not about basketball, this one about community gardening. Yes, just as exciting as a game of basketball, of course. A family has a plot in a community garden. The family is going to plant vegetables, flowers, or both. The diagram shows the area used by one vegetable plant right here, and the area of the entire plot right here. This number is very important. The area F in square feet. All right, so we have a different variable here. We're used to x and y, but that doesn't mean it can't change once in a while. It will. Instead of x and y, we're using F in square feet of the plot left for flowers is given by F is equal to 180 minus 1.5 V. Oh, there's our other variable, V, where V is the number of vegetable plants the family plants. The number of vegetable plants the family plants. Yes, that's not redundant, of course. So, instead of x and y like we've been seeing, no problem. We can change up the variables as much as we want. X and y are the most common, but that's not to say it can't change on us, which it has. We have two parts to this problem. Well, you have two parts in order to get this done. Part A is to find the intercepts of the graph of the function and state what the intercepts represent. In other words, calculate the two intercepts and how do they relate, how are they put back into this problem. In other words, in the context of this problem, what do the two intercepts actually mean? We saw that before with the basketball example, where we talked about the number of free throws and the number of field goals. Same thing here, only this time with square feet and vegetable plants. And then for part B, the family decides to plant 80 vegetable plants. How many square feet are left to plant flowers? Okay, so you'll have to solve for that, similar to that last part in the basketball example. Instead of points now, we're talking about area, and we're talking about plants. But let's go back. Let me give you a little hint here. Let's go back right to the beginning. Always helps to, of course, write out the equation given to you, and then determine what an ordered pair, what one single ordered pair is kind of telling you in the context of the situation here. F, what does F represent? Well, if we go back to the problem, F is in square feet of the plot left for flowers. So what is this really saying to us? F is the area for the flowers, not for the vegetables. That's just the area allowed for the flowers. And V is the number of vegetable plants. That's not area. It's the number of vegetable plants. The number of vegetable plants. Knowing that, you're able to solve it with a little extra help. One last thing to keep in mind. Because F is the area for flowers, keep in mind the unit of the area there is going to be in feet squared, otherwise known as square foot, of course. And as you can see right here, it reminds you of that. Area is equal to 1.5 f squared, 180 f squared. So when you're dealing with the variable f and you're replacing that with a number, keep in mind the unit is in square feet. What's the unit of V? Well, it's just a certain number of vegetables. So it would be like 3 vegetable plants, 4 vegetable plants, 5 vegetable plants, 1 billion vegetable plants, whatever it is that you calculate. All right, so there you have it, folks. If you have any questions, feel free to contact me. I'd be happy to give you a hand. Otherwise, good luck.